One of the fun things about Pelican is we're starting with a clean slate. And as opposed to some of our Condor tutorials where we have the opportunity to make them better by better and refine them over decades, we're having fun doing lots of new things from scratch. So this is the second version of this, right? We did a dry run before? First version. Okay. So we benefit from this as much as you guys do. We really enjoy trying to develop new materials. And last year we talked about how do you set up a origin service and connect to the OSDF or any Pelican run data federation. Uh, this year we took off our administrator hat and are trying to put on our user hat and think about what is the user point of view, the client point of view, how do you use and share your scientific data with Pelican. So to give that, we have Andrew. Take it away.
All right. Everyone hear me well? Great. Okay. Um, yeah, so I'm going to be talking about using Pelican for accessing scientific data, especially through the OSDF, but in principle, these lessons apply to any deployment of Pelican. Got some slides here, and there's also going to be some hands-on exercises. So if you are interested in seeing what it's like to use Pelican, now is the time. Get a web browser ready, and we'll get going soon. I have the slides at this go.wis.edu link. You can also find that in the schedule, along with the GitHub repository and the OSPool notebooks links that we'll be using in a bit. Okay. Oh, I even have a slide that says this. So all of the things I'm going to be talking about, materials, are either in this GitHub repository or links through it. This is just under the Pelican Platform Organization Training-Clients. So we're going to do a quick start here. Before I start getting into all the details about what is Pelican and how does it work, we're just going to use it. So to do this, we're going to use a guest notebook through the OSPool notebook interface. If you're not familiar with this, this is a way to test drive what submitting jobs on the OSPool would look like. And once that's set up, we'll open up a terminal tab in that Jupyter notebook. So in your browser, you're going to go to this notebook.ospool.osg-htc.org. And I have some slides demonstrating it. So when you go to this page, you should see a sign on button, sign in with CI logon. Go ahead and click on that. You'll be taken to a CI logon page, courtesy of Jim Basney's Use Token Emporium. And make sure you select your institutional ID from the dropdown. Our guest notebooks have disabled the social logins like Gmail and Orchid ID and things like that. So use your university email and hopefully it's in that list. If not, feel free to follow along. I'm going to be demonstrating this as we go. Choose your institution. And once you sign in with however many factor authentication you need to sign in with, you should see at least the guest accounts option here. If you have an AP40 account, you might see this other option like I have. Make sure you select the guest account and then hit start. Might take a minute or two for that to start up, but then you'll see something like this, and we want to open a terminal. So again, all these instructions are in the GitHub page, and that's linked through the schedule documents. I'm going to go ahead and do this here, maybe. There we go. Yeah. Controls. Okay. So notebook, OSPool, osgacc.org. I'm hoping if you search for that on the search engine, you'll also find it there. Sign in with CI logon. Again, choose the institution ID. Oh, hey, that's convenient. But you can also just type in the short version of your name and it should pop up. I'm not going to remember selections since I have no idea who owns this computer. I'm going to sign in with my net ID. I don't need my email in there. There we go. Now for my 5-factor authentication, maybe. There we go. No, it's not my device. Now, if you're signed in on your browser, that was hopefully just redirected you automatically. Um, so I see something like this here. I'm going to make sure I select guest accounts. I'm going to click on start. You'll see something here about the server starting up. Like I said, it shouldn't take too long, although I don't know what it's like if, all 80 of you decide you want to do this in your browser. I think we can go up to 40. We should be able to handle that, so we'll see. All right. There's a lot of complex infrastructure behind the scenes set up courtesy of Brian Ademir and Brian Lin with Kubernetes and Blackmagic, and I assume at least one sacrifice. Um, but if everything works well, then we'll see an interface that looks like this. On the left-hand side in the file navigation is a folder, Pelican Training Clients. You'll want to go into that folder. This has the materials for the training this afternoon. There are some notebooks here, so if you really hate typing things yourself, you can go ahead and open up the Quick Start notebook. I think there's some utility in doing this a little bit more manually, so I'm going to open up the terminal here. And let's see if I can get all this a little bit bigger. Is that a little easier to see now? Okay. All right, so this was step one. This is mostly just to get us a terminal that has the software that we want. And from here on out, we're just going to kind of work out of this space here. This is more of a convenience thing. You do not have to use this setup. And I'll talk about that in the slides here. Okay. So the next thing that we're going to do is we're going to find some data to download. So in a separate window of your browser, you're going to go to this nice OSDF services page. Again, this is linked through the various places, but I'll also show you how to navigate to it from the main website. You've seen this page a couple of times throughout this week already. It's got that nice list of data repositories that are already connected via the OSDF. Find one of those entries. I'm going to be using the route views one. And inside of that, if you scroll down, you click on one of those rows and you scroll down, you'll see download a public object. There's a command there, a Pelican objects get command. That's what we want to run in the terminal to download the data. All right, so I'm going to go ahead and do that here. I really should have put that into another tab. Sweet. We're going to do that. All right, so I'm going to go to the main OSG website here. And of course, I'm doing a live demo over the internet, so who knows what will happen. Under services, we have OSDF, and under that, there's overview, projects, and data. Each of these pages has some interesting things. If you haven't checked it out already, I highly recommend it. We're going to start with the data section. So under data, we see some different things here. Explore the OSDF. There's this nice table with a bunch of different data repositories that are already available through the OSDF. The team spun this up in like 12 hours 2 weeks ago at the request of the NSF, so it was really a Herculean effort here. And there's the nice numbers that you like to see about OSDF. I'm going to work off this route views example here. So if I click on that, I see some information about what is the route views data set. And if I scroll a little bit more, there's download a public object with the Pelican clients on the command line. We're just going to copy and paste that command and drop it into the notebook. So I'm going to paste it in, hit enter, and it was very quick, but there was a progress bar. And if I take a look now, I see that there's this new file, whatever this rib file is. I have no idea what this file is. But we downloaded it using Pelican and the OSDF. So congratulations if you made it this far. That's really all you need to know. Everything after this is the fun details about what's going on. Okay, slides. All right, so we took a look at this data page, and like I said, there's a bunch of repositories there. Feel free to check all that out. It's all very interesting. And we clicked on one of these rows. grab this command here and just pasted it into that terminal. Here I managed to catch a screenshot with the progress bar. Depending on how long that transfer takes, if you're doing a couple gigabytes, you'll see that stick around for a bit more. And then we get the file. And you're done. Okay, so if you have that notebook open, go ahead and keep that open. I'm going to go into some more details about how Pelican works and what the hell even is Pelican. And then we'll do some more hands-on exercises to explore its functionality from the user perspective. Okay, so what did you just do? And this is going to be an introduction to the Pelican platform. So what did you do? Well, you just followed some seemingly arbitrary instructions from a more or less complete stranger. So it's a good thing that there's a trust relationship established here between you and the OSG and the staff involved. Otherwise, that could have been an interesting party. So there are three main things that we did in this example. So first was we found a data repository that was available via the OSDF. We found a Pelican URL that listed where that data was accessible from using the Pelican protocol. And then you downloaded a corresponding object using a Pelican client. And so we're going to look a little bit more into each of these pieces to understand what is Pelican and what is it trying to do to connect people with data. All right, so exploring the OSDF. If you're not already familiar with the OSDF, maybe this is your first day here. The OSDF is a system that connects disparate data repositories as part of a single nationwide network. And using the OSDF, the providers of the data can make their data sets available to a wide variety of users, from working out of the browser to doing something like the notebooks that we were just doing, to using something like the OS pool for doing high throughput computing. The OSDF is run by the OSG as part of the fabric of services under the OSG, and it's running software developed by the Pelican platform. So just like how HT Condor runs the OS pool, Pelican platform runs the OSDF, or rather it's used to run those services. And this is one of the other pages here from the main website. You can check that out for more information about the OSDF. But you're going to get the tour here anyways. So I briefly had this up on the screen. This is some of the information about what the OSDF is currently doing. 46 repositories, transferring on average at a rate of 127 hertz. So yes, we get to go into the physics realm and measuring our data transfers. And then in the hundreds of petabytes transferred in the past year. So this is already working at a very large scale, and it's only growing. Oh, and I even say that on the slide. So what is the OSDF and how does Pelican platform work into this? Well, the Pelican platform is a software suite for creating data federations. What is a data federation? Well, a data federation unites the data contributors and the data consumers under a single namespace and a single access model. For the data contributors, they get to connect their existing data stores to the system just by running a simple service, and they get to maintain their access policies. They're not surrendering their data. They're not transferring ownership of the data. They have control over who gets to continue accessing it. On the other hand, for the data consumer, having this data in a federation like the OSDF is really convenient, because once you know what that federation is and how to interact with it, it's your one-stop shop, regardless of whether the data is stored on S3, it's on POSIX, it's on stone tablets in the backyard. It doesn't really matter as long as there's a corresponding Pelican service that connects that data to the federation. Okay, we already took a look at this table. Like I said, it's pretty cool to see all the data that's connected via the OSDF. And your data repository could be in this list. If you have data, open science data that you want to share with the community, whether you wanted to share it with the entire community, or if you think there's just a subset of the community you want to share it with, you can make it available through the OSDF. And if you're even a tiny bit interested in this, please do reach out. Talk to Christina, myself, Brian Bockelman. We're all happy to get you started down this path. You can also send us an email at the general support address. Okay. So that's what the data federation is, and more or less what the OSDF is. Now is for how do we actually specify data within that federation? And that's where the Pelican URL comes into play. So every data repository and every object connected via that repository has a unique Pelican URL. And as the data consumer, this is the only piece of information that you need to know to access the data, assuming the data is publicly accessible by everyone. Authentication is a whole nother rabbit hole that we're not going to cover today. Um, we can talk more about that offline. So this command that we copied here contains the Pelican URL. So that's this OSDF colon a bunch of long strings that ended in that name of the file we eventually created after downloading the object. So understanding what this Pelican URL is really mostly the only information that you, the consumer, need to know for accessing data via the OSDF or via a Pelican federation. And conveniently, understanding this URL also helps us understand Pelican and how it functions. And so this is a tale of Pelican in 4 parts. There's the first part, which is the protocol. Second part is the discovery URL. Third part is the namespace prefix, which we often just call the namespace. And then there's the last part, which is the object name. And for example, here is a full Pelican URL. If you've looked around at our documentation at all, this is our Hello World example for downloading something through the OSDF. We got the protocol on the front, the discovery URL afterwards. Then it's the Pelican platform, and then this test hello world.txt is the object name. So we're going to go through each of these parts here. First is the protocol. So what makes a URL a Pelican URL is that it starts with this Pelican prefix for the URL address. Pelican is an open source web protocol. It's an extension of HTTP. And this protocol establishes how to interact with a Pelican data federation. If you know how to speak the Pelican protocol, then you know how to talk to a data federation, which means you know how to get data from a data federation. The next part is the discovery URL. So the Pelican protocol interacts with the data federation. How does it know which data federation to interact with? Well, that's what the discovery URL does. It specifies what is the federation that this URL belongs to, and thus what the protocol should be talking to. And so for the OSDF, this is osg-htc.org, pretty simple. And that is, so far what we're constructing is the Pelican URL for talking to the OSDF. Now, one thing that you'll see throughout our documentation and later in these slides here, because the OSDF is our flagship federation for Pelican, a lot of us got tired of typing Pelican osg-htc.org. And actually, that's not true. OSDF was around before Pelican was. But you can think about it, OSDF colon 3 slashes is a shorthand for specifying the protocol and the federation name, just all gets smushed into 4 letters. So throughout these lines, wherever you see OSDF colon 3 slashes, that's exactly equivalent to this Pelican discovery URL name. Okay, so I'll have those up alongside so you can understand the equivalence as we continue. There's a namespace prefix, or what we often just call the namespace. So when a data provider connects their data repository to the federation, they register it under a namespace prefix. And the data provider gets to decide who gets to access data via that namespace through the federation, and they have control over all other subsequent URLs that have that same prefix. So here, the Pelican platform development team, operations team, we own the Pelican platform namespace. And so everything that you see that starts with this prefix belongs to Pelican platform, and they control who gets to access the data available through that prefix. And then lastly is the object name. This in some fashion maps to actual zeros and ones on a data store somewhere connected to the federation via Pelican under this namespace. So this is a single string. You will note that there is a slash between test and hello world. That is not necessarily a directory in a file because Pelican uses the bucket objects approach. But behind the scenes, this almost certainly does map to a POSIX style test directory hello world.txt file. Okay, so if you know the Pelican URL, and then you can use the Pelican protocol to get the data through the federation. How? Well, if you were paying attention earlier on, there is a command that you can do, and we'll talk a little bit more about what that is. But what happens when you run a command like that? How does Pelican, as this data delivery system, actually get the data from that data storage to your device where you're running the command? Which leads us into this scenario. There's you. You want some data. There's a data provider who has data, and you want the data. So you say, hey, can I have the data? And the data provider's like, yeah, sure. It's an S3. You know how to use S3, right? And if you're like me, then the answer is a bit of an awkward silence while you try to figure out what to say. So you don't necessarily know how to speak S3 or whatever fancy new protocol comes down the street. But you still want to get that data, right? You have science you want to do, you want to access that data, and the data provider wants to help you access that data. But they don't necessarily want to change their storage system behind the scenes just to accommodate this one user. So this is where a data federation comes in. This is serving as sort of a middleman between you and the data provider. And this data federation is identified by well, it's using the Pelican protocol, and it's identified by that discovery URL. Now, the data provider integrates their data storage system with the federation via something that the Pelican platform calls the origin. You don't really need to know any of the details about what an origin is or even how it works. You just need to know that this is plugging in the data storage to be available via the federation. And the way it does that is it becomes available underneath that particular namespace that was registered when the origin was set up. And like Brian Bockelman said, we did a tutorial on setting up an origin last year, so you can take a look at our materials from then. Now, the one thing that you do need to know about the origin is that it knows how to map that object name that you provide in the URL to the actual ones and zeros on the disk or on the tape, wherever it is, connected via the origin service. So you, the user, just need to know the Pelican URL. You don't need to know any of those nasty details about tape and robots and whatever else is going on. And if you have that URL, you can get the data. So we're going to put that URL in our pocket here because we still have to talk about a few more things. Mainly what we need to talk about is the client. So if you have the URL, then you need to talk with the Pelican Federation via this client, and you give it the URL, then the client's responsible for going out into this magic system and bringing the data back. Okay, now at a first pass, you may be thinking, okay, we got the client, we got the origin with the data, it just downloads it, right? Well, there's a very simple reason this is not the case, and that's because what if there's many origins, right? Which one has access to the data that you want to download via the federation? In principle, you could go down the line and ask each and every single one of them, hey, which one has my data? And that may or may not be slow or fast or work at all, but that's not really convenient. So Pelican has this other service called a director. This operates at the level of the federation, and the director knows where the data is. More accurately, it knows which origin belongs to which namespace. Okay, so with the director's help, we can take down however long that list of origins is to maybe just one or two, depending on what the data is. And that should solve our problem, right? Cool. I'm ready to go. And you as the user decide, let's do this 10,000 times, okay? Or if you're like Eric Wright earlier this month or earlier this week, you want to do this 30 million times, right? And the data providers over here, like, I'm sorry, no. There's no way I'm going to let you download, this 10 gigabyte container 30 million times from institutions across the country, right? That is well, I'm not a computer scientist, but I believe that's the definition of a denial of service attack. So this is not settled here. We need some way to be able to repeatedly access data through this system, or at the very least, we need some sort of throttling in place to prevent overwhelming the data storage. And that's part of what the origin does. But another way to help with this is the cache. So this is the fourth component I'm going to talk about here. And this is the cache. And what the cache does is it sort of sits in the middle and says, hey, for the origin there, I'll download your object once. So once I download it, I'll leave you alone. And then it turns around and tells the client that just download this how many times you want, and I'll have it here for you. Everyone's happy with this. There's never any more problems. We've solved world peace, and everything's good to go. So Brian Bachman will be talking after this tutorial about what are the problems and how do we fix them. But this is the core concepts behind the Pelican platform and its infrastructure. I am omitting a bit of information here about the director, and this lives inside of what we call the central services. There's some more machinery behind the scenes, and that's what Patrick was talking about earlier today to some extent. But for our purposes, we're just going to ignore that, because as the end user, even if you do encounter an error, it's almost certainly not going to involve anything that's not already on this screen. So if you encounter an error, it's probably going to have one of these words in it, and that will hopefully help explain what's going on here. Okay, so very briefly, how did these four parts work together? Clients, once you give it to the Pelican URL, the client goes to the director and says, hey, I want the data corresponding to this URL. The director tells the client, here's some caches for you to try. Client talks to the cache. And if the cache has the object, and if the client meets some access requirements for accessing that object, then it gets to download the object from the cache. And then you're done. Now, if the cache doesn't have the object, it turns around and asks the director, hey, I need this object. Where can I get it? It tells it which origin to look at. And then sort of the same story. If the origin service decides, yes, this is a valid access request, you can download objects via me. It gives the necessary information. Cache keeps a copy of it locally in case the client comes back and wants it again. And then the client also gets the copy. And then you're done. Okay, so there's a couple other things, or there's a couple of important things to note about caching. First and most important is that Pelican assumes that objects do not change. Now, this seems kind of silly, right? Oftentimes your files are changing on your computer at a pretty frequent basis. But because of this caching system, and because the client isn't always going back all the way to the origin to get the objects, it's important that the object in the cache matches the objects available via the origin. And if you change the file or change the object at the origin or accessible via the origin, then what's at the cache no longer matches. You get these, differences. Some of your clients will get the old version. Some of your clients will get the new version. And depending on some technical details I don't fully understand, you can even get a Frankenstein version. That's a mix of the two. So Pelican assumes your objects do not change. If you change your object, change the name of it at the storage so that it has a new object name within the federation. Requirements for accessing an object are respected everywhere in the federation. So just because the cache downloaded a copy from the origin does not mean anyone can download it from the cache. The cache respects the same set of rules that the origin uses for determining who gets to access that data. And I mentioned this earlier, but caches help prevent the data repository from being overwhelmed, because if we do decide to kick off, a 30 million job workflow and they're all using the same container, that 30 million pulls can hit the cache instead of hitting Docker Hub or whatever your storage system is. And this leads to what the main advantage for using the OSDF is. So the OSDF maintains over 30 caches across North America and Europe. These are mostly high-performance servers established on internet backbones, which means they have very good network pipelines. And so if you connect your data to the OSDF, you already have a very well-established distribution and caching system through which to send millions of objects every year. Okay, so thanks for listening or not listening. It's okay if you didn't care. At this point, though, we're going to talk about using the clients to actually get data from these federations. So go into a little bit more detail about the clients and how you can use them. So Pelican provides several clients for interacting with its Pelican federations. There's the Pelican CLI. This is the command line interface that we actually used in the quick start. There's the Pelican FS, which is a Python implementation. And then, of course, there is the HT Condor plugin so that this works with HT Condor jobs. So the Pelican CLI, or short for command line interface, I'd say this is probably the primary way of using a Pelican client for interacting with the OSDF, at least manually interacting with a federation. Conveniently, this is a standalone binary. So you just need to download this file from the internet, assuming that you trust us. And then you don't need to have admin permissions or anything like that to install it. It doesn't require you to actively accept license agreements or anything like that. I mean, you do need to accept our license, but you don't need to enter the letter yes or the letter Y to confirm it. And so it's very easy to obtain and very easy to use, regardless of what system you're on. Pelican FS, as I said, is based in Python. It's built on top of the FS spec Python package. Honestly, I did not know this was a thing until I had to start preparing materials for this client. So if you don't know what that means, it's okay. You can still use it. And it's available to install with pip. I have /conda here. I don't remember if you can get it with conda. You can? Sweet. The developer of Pelican FS says you can get it with conda, so hooray. And then there's the HT Condor plugin so that you can use these Pelican URLs in your submit file, and that's it. Everything is handled behind the scenes by Condor. This is built into Condor. Some basic client actions. First one is to LS, or list, the objects that you can access via a federation. There's get, which is to download the objects via the federation. And then there's puts, which is to upload an object via the federation to the store that's behind the namespace. Now, the asterisk here on puts is you always have to authenticate a put action. That's another layer of complication that we're not going to cover today. But if you are interested, we're going to be giving a tutorial at PERC that covers this as well. So if you're going to be there, feel free to stop by. Now, LS and GET, those can also require authentication. It depends on how the data provider has set the permissions for accessing the data via their namespace. But if it's publicly available data, then you don't need to provide authentication. All right. So we're going to start with Pelican CLI, and I swear we're just a slide or two away from hands-on stuff again. So like I said, the CLI is a standalone binary. It does not require admin permissions to install. Available for Linux, Mac OS, and Windows. I will caution you, though, most of our testing is on Linux. We're a little less covered on Mac OS and Windows. So please feel free to reach out if you run into any issues with those. And then to install it or to find this page, you can just go to the documentation. This is already in the OSPool notebooks that we started up at the beginning, so we don't need to actually install it here. Once it's installed, you'll have the Pelican commands, which has a noun-verb syntax, and the commands for interacting with it as a client are available through the objects noun. So with the CLI, most of your commands are going to look like Pelican objects, I want to do something, and then the Pelican URL. All right, now we can start running commands in the terminal here. So first step, we're going to look at listing objects. Like I said, we can use the ls command to list objects. So this in general looks like Pelican objects ls and then the Pelican URL. So for example, we can do this Pelican object ls command, and I'm going to use the OSDF shorthand. We're going to look at what's in this Pelican platform /test. And remember, OSDF is short for the full Pelican discovery URL for the OSDF, and these are exactly equivalents. Whichever way you enter the command, it should work the same regardless. So I'm going to do it like that. All right. So in your OS Pool notebook, go ahead and run that command if you have not already. I'm going to see if I can make this work here. Da, 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 da. Cool. All right. So I'm going to go ahead and run that command. And like I said, there is Jupyter notebooks for each of these parts. So you could also just do Shift Enter on some cells, and it should work as well. All right, so I just ran that command, Pelican object ls, and I gave it the Pelican URL that I wanted to look at. And we see that there's these two objects accessible via this namespace. Looks like Marwan has a question.
Yeah, just to give you a hard time, even though you're not responsible for this. Why, in heaven's sake, since you're already, when I give you OSDF, you know a lot of stuff and you add, why, in heaven's sake, I have to do this dot ///? Is that my dues to be paid to the goddess of slashes? Yeah, no, I don't like the presentation that I give you an object and then I give you a URL. You're giving me a name in the OSDF namespace. Why do I have to have this URL language in your tutorial? Why do you call it a URL? It's a name.
I'm calling it a URL because of the : / syntax.
But this is stupid.
Okay.
No, it's annoying. Why? And then I forget that a backslash, or I am coming from another operating system, and I write my backslashes in the other way, or it makes no sense.
So you can specify the federation manually.
Yeah, but why do I understand that I can write in, it's like saying you can program in Lisp and then here's Lisp, but you can also write assembly code.
It's like I did that wrong.
No, nobody with a right mind should write all this crap. I mean, you have an OSDF, which is the name of the federation, and you have an object name or in the federation namespace. Why do we have to use URL and backslashes? I know it's not your responsibility, but I think as a facilitator, you have to realize that that is, I would say, unacceptable. Why 3 and not 5? I mean, if it was a question mark, I would have understood it, but.
Brian?
If you don't want to use URLs, the command line or the binary name is OSDF. So
I tried that. I don't think it's working in this.
No, scroll up to where you last tried. You left off the object.
Okay.
Yeah.
Objects. Okay. So yeah, we can do OSDF objects and then give the object's name there. I guess you don't need the leading slash.
Why do I need that? Why do I need a leading backslash? I mean,
Apparently you don't.
it's bad enough that I have a backslash in the middle, but that's a different story. At least it's not that it's underlined from Unix land. I mean, we have to think about what normal people are used to in terms of namespaces.
Interestingly enough, I think normal people might be used to URLs. There's one at the top of the window there, actually.
Yeah, that's fine. But we are not URLs, and we are not dealing with the people may be used to URL when they are using the web, but not when they go to the grocery store, they don't say, "Give me this URL."
So the comments was if you don't have something like : // then you might confuse it for a local file instead of something accessible over the internet.
I would argue that it should look like a local file. And but you talked to Pelican and you told it that it's in OSDF. And now tomorrow morning you may use the same command and say my local federation, and that might be your local file, and it may have the same name. Okay.
All right. Well, based on that commentary, I think Marone's really going to like the Python package that Emma has written. It helps address some of these comments here. So bear with us through that next part, and hopefully that will help satisfy some things. You can get some more information. So you can do ls-l or -- long, and this will show you the size of the objects and how long since they've been modified or something like that. To get an object, this kind of works like a copy or an SCP command. So Pelican object get the original location or the URL that specifies the location via the federation, and then what you want the local destination to be. And so we can run those commands in our terminal here. Pelican object gets, and then the protocol for specifying it. So I'll go ahead and type that in here. And this isn't a very big file, so it should go through in a matter of seconds. And like I said, there's commands in the Jupyter notebooks if you want to run through this on your own. Okay, so I did that, and if I take a look, there's going to be a new file called helloworld.txt made locally. And if I take a look at that, it says, hey, we transferred files with the OSDF successfully. All right. You can recursively get objects as well using this recursive query appended to the end of the address. And this will download all the objects accessible via that prefix or via that address from the federation. So in this case, we're looking at this test prefix here. And let's say instead of hello world.txt, I just wanted everything that started with that same prefix. So I put recursive at the end. And if I hit enter, there's going to be a new directory, ls test, and that will show us the same local copies of the objects that are accessible via the federation.
Again, I understand that at the moment you must put everything into a single string that you pass down, and you treat it as a URL that then you unpack it, all this crazy stuff. But why, since Pelican is a command that you control, why don't you make recursive part of the recursive? Yeah. Good. So it should be and stop exposing all the dirty laundry that somebody decided that everything should be pushed into a URL.
Well,
which hopefully we will break in the not too far future.
well, the reason I'm showing this dirty laundry is because for the HT Condor plugin, this is how you have to specify these things. So if you want to get data,
I think that this is something that needs to be addressed at the it's a JDL.
yep. And I've got a proposal in the works to address
Okay, good.
Yeah. Okay. So that's how you can get objects recursively. And as Marone pointed out, you can use this dash dash recursive option with the CLI to specify the same information as we would with that question mark query. Okay, onto the Pelican, onto the Pelican, onto the Python clients. So this is the Pelican provides the Pelican FS package, which is a Python package you can install with pip. You don't need to do this in the OS Pool notebook. This provides a Pythonic interface for interacting with the Pelican Federation, getting data or just streaming data directly to your notebook. Now there is you should have already done this earlier on. That's an old slide. I'm going to skip over some of the stuff here because this is how you would manually invoke it with Python code. Basically, there's a class you got to import. You instantiate it with the discovery URL. Once you have that object, it's got some methods built into it that will allow you to do the same transfer and LS commands that we've discussed with the CLI clients. And this is all in Python language, so if you're used to working with Python, this should all be pretty familiar. I'm going to skip ahead to what I think is actually kind of the coolest feature about this package. So a lot of packages understand FS-spec, and behind the scenes will use it to fetch data. And Pelican FS can leverage that same power to be able to transfer data to your Python code. So there is a script that already has this sort of setup. We're just importing pandas, and we're telling it this Pelican address for the object. And automatically behind the scenes, it's going to use the Pelican FS package to transfer that data and allow us to use it. So in that script, I am not referencing Pelican FS at all. All I'm providing is that Pelican address, and it knows what to do with it. So let's take a look at that script here. All right. So we have this autoload.py. It's a pretty simple script. So import pandas. We define that address within the OSDF. There's a very specific CSV file that I'm asking it to pull. And then pandas, I give it that that address. Pandas will automatically load it, and then I'm just printing a little bit of information about it. So if I run this Python script, there we go. So I did not manually invoke Pelican FS. All I provided was that Pelican address as the file that I wanted pandas to read in. And it automatically behind the scenes used the package. I have my data, and I could do whatever it is I wanted to do in pandas with it. I think yesterday Harsha was demonstrating some similar usage, but with Xarray to do a very similar thing. And it's a slightly different implementation, but it should make your data analysis and data processing in Python be a lot smoother for interacting with the OSDF and similar Pelican federations. Okay. So I ran that, and like I said, behind the scenes, Pandas knows that it needs to talk with the Pelican FS to figure out how to get this data, and it all happens behind the scenes.
Previously, when you do it, you get a copy of the object on disk, right?
Yep.
Here, do you get a copy of this on disk, or is it just going into memory and then gone?
So the FS spec layer decides what to do with it. If it's small enough, it just puts it into memory. If it's large, it'll make a copy of it on disk somewhere.
Yeah, but that's my problem. The semantic is fundamentally different. Is it, want to have a copy of the object on my local disk because I want to use it? Or is it I just want to get something on the screen and it's gone? It is.
It depends how you want to do it. Both options are available.
But what's the name of the local file when I get the object in?
Well, if you're doing it manually, then you get to decide what that name is.
Do I have to provide? Okay.
Yeah, so I can show you what it looks like here. I have this object, I give it a get file, and I provide the name within the namespace.
Then you give it destination.
Give it a destination. Yep. So if I want to save it as helloworld.txt, I can do that. If I wanted to call it something else, I could.
Fine. I understand. I just want to make sure that it's understood when you use the DFS, it is sort of more designed for, I don't know, as part of an application that you read things into memory.
Right.
And when you do a get of an object, it is more designed to create a copy on the local. And I think it's important for your audience in a tutorial to understand that these are two different usages, if you want, for SDF.
Yep.
Do you want to get a copy in memory in an application, or do you want to get a copy on disk?
Yep. Right. Yeah, and so if you did make a copy of the file locally on disk, then you could just use the usual Python ways of opening it up and interacting with it to do your analysis. Okay. So not all features of the underlying FS spec are available within Pelican FS because the Pelican client interacting with the data federation is not a proper file system. So that shouldn't be too much of a surprise to anyone. And I'll say the Pelican FS is still in development. It's still a pretty recent release here. So please let us know if you run into issues or bugs. Okay, so accessing data using Pelican and HT Condor. This is really where we can see Pelican and Condor shine together. So Pelican is tight integration with HT Condor. And what's really nice about this is this Pelican address. You can use it in the submit file or the JDL to declare data that you want to have transferred via a federation. And because Pelican ships with HT Condor, this should all just work out of the box if you have a release of Condor from the last year or so. And what's really nice about this is HT Condor manages the file transfers. So if you're used to having to have error checks inside of your executable for, hey, did I download my data correctly from this storage? Now you get to leverage the power of HT Condor for managing file transfers via the OSDF or via Pelican Federation. And that means errors are either going to be automatically retried or they're going to turn into holds so that you know you need to change something about how you submitted your job. Okay, so just like any other data that you want to transfer via for a Condor job, you need to declare it in the submit file in the JDL. So when you do that, you just provide the Pelican address for that object for accessing it through the federation. And you can use that in transfer input files. You can use it in transfer output files if you have the right credentials. Again, that gets into authentication, which I'm glossing over for today. So to demonstrate this utility, we're going to work with an example from the NOAA climate data sets, specifically this global historical climatology network. There are thousands of stations of weather stations that have been collecting data for decades and in some cases centuries, and this data repository has that information. So this data set is already connected to the OSDF through Amazon's Open Data Repository. So the namespace for this data is under AWS Open Data. It's under the US East one, which I don't know AWS, so I don't know what that means. And then the S3 storage is underneath this NOAA GHCN PDS namespace prefix. So altogether, the address for it within the OSDF looks like this. I don't remember why, but we can't LS that location right now. I can't remember if it's the provider's requirements or it's a technical limitation. If you were to browse through the S3 interface, then you would see a structure that kind of looks like this. Now, because this is S3, this is not necessarily a directory file tree, but this is the organizational principle behind the object names. So there's this list of stations and their IDs, and under the CSV and by station prefix is the CSV files with the station IDs as the identifier. So in your notebook is the HD Condor plugin directory. So go ahead and move into that. Again, there's another Python notebook in there where you can run through, or sorry, it's a Jupyter notebook, not a Python notebook, with the commands for doing. I'm going to be running them manually here. There is a Pelican object get command for getting the stations list, and I'll go ahead and copy that. Actually, I think I will just bring up the notebook here. All right, so in the Jupyter interface, there's this folder, HT Condor plugin, and we go into there. We see a few different things. We want to take a look at this Jupyter notebook. And this is some of the same information I was just talking about here. This is also in the GitHub repository. But we want to get a copy of the stations list. So to do that, there's a particular object get command that we want to run. There's a particular address within the OSDF that we want to look at, and we create a local copy of it on disk. So if I run that, I can then use head to go ahead and take a look at what that looks like. We see a bunch of rows of data. Hooray! It's a list of station IDs. What all these columns mean? Who knows? But the first column here is the station ID, which will allow us to obtain the corresponding CSV file. And in fact, that's what the next command is doing here. So it's a different OSDF address here now underneath the CSV by station. I picked this particular station ID because this corresponds to the Dane County Airport's weather station. So most of you probably flew in through there, and that's the data we're going to be looking at. And I just make a local copy of it here on disk. Taking a look at it, we see that there are some columns and lots of rows of data. You're welcome to dig into what all this information means, but mostly it's a way for me to run this Python script that I included in the repository. So there's this example.py. It takes a station ID as an argument, and if I run that, it spits out some information about the data sets. So this is 85 years of data. So they've been collecting data at the Dane County weather station there for 85 years at least. And when I run this Python script, it's going to create an image file, this .png file with the same station ID. And you will all be shocked to learn that during the winter, it's colder than during the summer. That is the extent of my climate's analysis ability here. But basically, this is just a distribution of the lows and highs by meteorological season. So if we look at the winter, these are shifted, lows are just under 20 degrees Fahrenheit, highs are maybe centered around 30 degrees Fahrenheit. And if we look at the summer graph, oh, hey, would you look at that? The lows are centered around 60, highs are centered around 80. So I am now a climate scientist. If anyone has an open position, I may need it soon, we'll see. But this is just an example. This is a toy example here. If you are actually a climate scientist, please do talk to me because I would love to do a proper sort of analysis on this data to give people a real life example. So that is the thing that we want to do. Cool. All right. Now let's say that I want to do this for all the stations in the NOAA data set. Well, there are almost 130,000 weather stations in that data set. Okay, that's not too bad. This only took a second to run or so, which means that if I wanted to do all 130,000 of them, I just need to set my poor computer loose for a couple of days. And at the end, I should have 130,000 images. Let's set aside for now the question of how big is the data. So there's a lot of compute to do, but let's say I actually did want to do a proper climate analysis. Maybe I wanted to look at the trajectory of the temperatures over the decades. Well, in that case, let's assume it takes an hour to analyze one station's worth of data. Well, I have 130,000 stations, and if they each take an hour to analyze, I am now looking at 15 years of calculation if I do them one after the other or in serial. Okay, I probably want to do something else with my life for those 15 years, so I'm not too interested in it. And of course, 15 years from now, climate science will have changed to the point that whatever my analysis was is probably not meaningful anymore. So this is where HT Condor is really powerful. So a system like the OS pool, this distributed high throughput computing, the users on the OS pool are regularly getting thousands of jobs to run at a time. And we saw just a sampling of this with Eric Wright's presentation on Monday, where he was getting tens of thousands of jobs to run at a time along with his students. So there's really a high throughput that you can get through something like the OS pool. And if we assume a modest rates of 1,000 stations per hour, that's about 1,000 jobs per hour, then I see that my analysis is only going to take 5 days. So 5 days to process what would normally take a regular computer in serial 15 years to do. Okay, so that's really the power of OS Pool and HT Condor. And where Pelican fits in here is the data movement, right? You don't necessarily want to have to copy that entire data set to your device and then have to upload it back to the compute system and then have Condor transfer it anyways. You can just specify Condor to transfer it through the OSDF from the very beginning. And so here's an example submit file of what that would look like. There's maybe a little bit more fancier construction of what the address looks like, but the core idea is that that's that same address. We're going to be looping over the station IDs that we have in the station list.txt. If I want to do all 130,000, I could do that original stations.txt file that I got through the OSDF. I don't actually want to do all of those. And then the rest of the submit file is just setting up, executing that Python script and getting the results back. So I do need a list of stations to work with. You can run this generate list.sh. If you look at it, it's just a very specific grep command, and it grabs 10 stations starting with the Dane County Airport weather station. And then once you've constructed your submit file, Condor submit example.sub works just like it would any other time. And if we did Condor queue, I see my jobs are in the queue. And I'm going to come over here and do Condor watch queue so I can see the progress of my jobs. All right. In newer versions of Condor, which are not yet running on this notebook, the Condor watch queue will also show when the job is in a file transfer state. So if it's transferring inputs, it'll change the status of it. So now you don't have to try and guess, wait, is it running? Is it transferring? We've separated those out. And here what we're seeing, it's running pretty quickly here. Of course, this simple example is not taking an hour to run per station, but it does kind of get to the heart of how Condor works. We can do lots of work in parallel here, distributed across machines. And if I take a look at my results folder, I'm going to see a bunch of different images. So since these are all weather stations in Wisconsin, I'm betting I'm going to see the same distribution here, that winter is going to be colder than summer. If not, then I'll probably want to take a closer look at my station ID list and see which station it is. Okay. So that was a whirlwind tour there. My slides here are just covering the same information here. Let's see. I think I do have some more things to talk about. Okay. If you really wanted to do an analysis where you looked at all 130 stations or 130,000 stations, please don't use our guest notebook for that. The guest notebook is just a toy example of what submitting to a high throughput system would look like. Behind the scenes, it's actually like 4 cores. So you're not going to get much work done there. If you do want to do a large scale analysis like this, please just request an account. You can do that through our website. You can send us an email. We'll help you get the ball rolling here. But you can use the OS pool to do this with a full account. Okay. So more information about Pelican. There's a Pelican platform website, pelicanplatform.org. Documentation is under docs.pelicanplatform.org. And information about the OSDF, you can find that through the main OSG HTC websites. We've already explored a couple of those pages today. If you have a data repository and you want scientists to be able to do compute on it, please consider connecting it to the OSDF. And if you're concerned about you don't want your data to be fully public, we can handle that. We can help you set up the authentication to make sure only the users you want to have access to the data will have access to the data. The one caveat is we cannot support legally restricted data such as HIPAA, personally identifiable information, or other restricted data. But if it's open science data and there's just a subset of researchers you want to give access to, we can set that up. And like I mentioned earlier, we're going to be at PERC 25. So that's, when was that, July 21st, I think. We're going to be giving a longer version of this tutorial. A lot of the same information. It'll be revamped with the feedback from this tutorial here. But we're also going to cover authentication. So if you're interested in what does that look like to do authentication with this system, we'll be covering that as well. And if you have questions about OSDF support, send us an email at the general support address. If you have Pelican-specific support questions, we do have a help address for Pelican platform as well. If you're curious and trying out some of these fancier things I alluded to earlier, feel free to reach out through that. Okay, so I'll open it up for questions. Brief acknowledgement. Thanks to the NSF for funding this and the Pelican platform. Yeah. Okay. Erwin.
Hey, Andrew, thank you for your talk.
Yeah.
I work for Research Server Infrastructure.
Yeah.
And as part of our storage portfolio services, we recommend to use Globus.
Yeah.
Could you run me, what would I, compare and contrast, please?
Yeah. Okay. So you folks recommend using Globus for transferring things. First I'll mention that one of our fellows for the summer is working on integration with the Pelican Federation and Globus. So that is something that we're targeting. As to what does Pelican do that's different from Globus? With Globus, this is peer-to-peer connections, essentially, right? You have to have Globus up at both sides. It's got to be a full server, more or less. I think there's some newer technologies there where you can have local endpoints. But there's always got to be a user on that other side. And with Pelican platform, because of the clients, you can just have that standalone binary. And with the caching infrastructure, we can do this at scale. With Globus, I don't know if it has a concept of or what it does if you try to download something from it 10,000 times at the same time. Whereas the Pelican Federation is designed to handle that out of the gate. Brian Bockelman could probably talk more about the Globus aspect.
If I saw a slide earlier this week that said the default limit for Globus is 3 transfers at the time.
The default limit for Globus is what?
3.
3 what?
Transfers.
Transfers. Oh, so you could do 3 transfers at a time with Globus?
So it's the way I tell it. Think of Globus as I want to take this directory of files at this cluster and move it to that cluster. And then I'm going to look at the shared file system in that cluster and read it. Where we're really pushing for Pelican is I have a repository with lots of interesting data in it. I want to feed a large, or maybe not even large, but I want to feed a high throughput system and get it all the way out to the client. So I view them as highly complementary, different use cases.
Piggybacking on Brian's comment and Andrew, is one way to address it is if you can come up with a handful of workloads. The researcher wants to do blah. As Brian said, I have a directory, I have whatever. Then you may come and say, this is the way I will do it with Globus. And then we can put next to it, this is the way you will do it with Pelican. And then let you compare between the two. Because I think these answering the question, compare them, is sort of, we are not competing with Globus. As Brian said, we would like to treat Globus as an object store. But I think the question is, what does it take to do something? And then you can look at how you do it on the Pelican and say, oh, that looks good, or this is awful, and I want my users to use this. Okay?
Hey, Stefan Piperov here from Purdue. I have a question which I'm already a little bit scared to ask because we remember the story yesterday somebody shared with us when they asked Miron if Condor doesn't need X, and then what happened to them. Anyway.
You can ask.
I will.
You can ask about why, and then you are safe.
I will. So my question is on the caching part, which I find obviously extremely useful and good thing. My question is Pelican able or planning maybe to be able to do manipulations on the data at the caching stage? And I will give two examples which might justify it. One of them is splitting. Now, we know high throughput computing thrives when we can split tasks into smaller pieces and run them in parallel independently. So in my view, and because sometimes data sets are produced by other people, not by us, and we might have these extremely large objects or files in the origin, and it might be better to process them in smaller pieces when we run through them. So one possible function here might be, and here obviously I speak from the perspective of high energy physics where we use root, and we know that root files can be easily split into pieces. So that might be one functionality which can facilitate the parallelization of the process. Another functionality might be decompression, which sometimes is a very expensive operation. And if one is able to get a highly compressed file from the origin and then have it decompressed or recompressed with a much faster algorithm in the cache, then the processing can be sped up dramatically, especially reprocessing when the cache is read multiple times.
Yeah, so I can't answer the general question about doing actions on the object at the cache level. But for the two particular examples you gave, I believe we already support those as it is. I'm not sure about the first one, but the compression parts, there is a query you can put on the end of the address that will automatically handle the compression. And this is covered in the documentation. But what's really nice about this, and we already have users using this locally with our system. Let's say that you have a large file or large object in your data store. It's in tar GZ compression, but you want it expanded on disk when it's delivered, right? You don't want to have a copy of the large GZ file and the decompressed file at the same time. You can decompress on stream, and in vice versa, you can compress on upload with this pack option here. And then as for the first example that you gave, my understanding, I'm not a computer scientist, is that Pelican works at a certain block size, and you can specify locations or specific addresses within that that you want to pull out without necessarily having to copy the whole objects through. And so I imagine it would be pretty easy to leverage something like that at the cache level, where you've got the full object at the cache, and then the clients are pulling individual pieces from it.
In the bigger picture, I will refer to it as subsetting, but operation on the object from the object store and what is being cached and what is delivered is highly on our roadmap. We are also looking at HDF5, and which is with NetCTF, which is popular among the climate community, and it's organized as blocks, and these files are usually huge, and the interesting opportunity here is can in the case of a job specify which block it needs, and then everything that was described here can be done at the block level, which is logical. And so the idea is to be able to stage derived data. We have another project with visualization where the data set has to be transformed to another index structure in order to be visualized. And then there is a question of how do you stage the transformed presentation before you deliver it to the endpoint. So that is definitely on our mind. And if you have specific examples, I know that Brian did quite a bit of work on root and smart access to object inside root. But if there are other domains, it will be of great value for us.
So if you heard Maron make the comment before, you can think of the origin as a cache, right, as well. And the origin, when you're reading a file from a file system, there's lots of code that goes on, a hard drive spins, lots of software happens, and it doesn't take a huge leap of to say, well, instead of only reading objects from disk, maybe things get generated, maybe things get subsetted. So at some level, it's a very natural thing to ask it. And maybe during year one of Pelican, we focus a lot on the P's and Q's, and let's make sure we have high success rates and things like that. But I think there's some really fun questions there around, do you limit yourself to only thinking very literally in terms of storage, or do you think very broadly about the naming scheme and how you reference things that are independent of bytes on a object store?
Yeah, I'll just, I guess, at this point, add me on subsetting and streaming at the origin or cache or near the data. I think that's super important and relevant for us. Also, I think Maron just mentioned HDF5 format. I was kind of curious whether the FS spec will push out there and presumably other formats that are maybe domain specific and useful. And then I just want to point out, I think there's a balkanization problem with data discovery that I observe, right? So you guys have just presented yet another list of data sources. There's NAIR has a list of data sources, Amazon has one, National Data Platform has one, and there are many others. And honestly, I'm not sure what the solution to that is, but somehow or another, we need to get our act together.
I just mentioned the problem of looking inside objects is really fun. The question of data discovery is very scary. That's they're related, but at least right now I'm purposely trying to not solve that problem because I think it's a big problem and it's one that we want to partner with people on more than take a shot of it ourselves.
Todd.
That's okay. Apologies if you already addressed this, but Pelican FS, would you recommend its use, or would you recommend avoiding its use in a batch environment like in HT Condor jobs?
Yeah, I was thinking about that. One area right now where I wouldn't want to use it in a batch environment is Condor wouldn't be involved in managing the transfer, because you'd have to launch your executable, and then specify the data that you want to download. That might be pretty nice for something like IceCube and what he was talking about earlier today, where they don't even use Condor for the transfer management in the first place. But if you do like the transfer management with Condor, then the FS right now is not good for that.
Okay, thanks.
Yeah. Rachel.
First of all, awesome job, Andrew. I really, really enjoyed that tutorial. I don't think I've ever had so much fun making very basic histogram plots. So really enjoyed it. I'm just kind of wondering, looking towards the future for Pelican, long time down the road, and it may be out of the scope for Pelican, but do you ever potentially see one day where there could be a GUI for it?
That is not that far down the road, right? Right, Brad?
I think Canon has it on his to-do list for July, something like that. Yeah, so
Coming soon.
the browser page that Andrew showed, there's one box that says copy paste, and there's another box that says just download. You click and you can download it straight from your browser. So it turns out that because we decided to engineer all of this on top of HTTP, it feels fairly native to do in the browser. So the two things planned right now are one, having, this is just a button to turn that into more of a GUI type browser interface and extend it for authentication as well. But the other thing I'd like to tackle is to think through what a Jupyter integration looks like, because that's another common environment, visual base that's not kind of just the browser.
All right.